Hi everyone. So sometimes when mathematicians find themselves doing a process over and over and over again for individual problems, what they will do is they will generalize the process, meaning instead of having like numbers for coefficients, they'll use letters instead, and they'll go through the same process that they normally do. In this case, we'll do completing the square. And what happens when they do that is it leaves them with a formula they can use instead of having to go through the process every single time. So I'm going to walk you through solving by completing the square in this generalized way. And at the end, you're going to see a very familiar formula. All right, so the first thing you're going to do in this process is to get rid of the x squared coefficient, because remember the x squared coefficient has to be 1 in order for completing the square to work. So let's see, that would be b over a times x over 1 plus c over a, and 0 divided by anything is 0. And then I'm going to move the constant to the other side by subtracting it. So I'm going to move the c over a to the other side. Now this is going to look scary at some points. That's why I'm doing it for you and not asking you to recreate it. I just want you to see where this leads and not have to do it on your own. Now I'm going to complete the square. So remember that completing the square is adding a blank, and to fill that blank you take the x coefficient and take half of that. So over to the side I'm going to write b over a times a half. So I multiply the top times the top and the bottom times the bottom. So half of b over a is b over 2a. And then square that. And on the opposite side, to keep the equation balanced, I have to add the same thing. All right. Now, this factors into a perfect square trinomial. And again, if we didn't know that pattern, it would be a nightmare to try to actually factor this. But since we know the pattern, it's easy. It's always an x, and then the thing that's inside this square is what goes here. Now, that's going to equal. Over on this side, I'm going to take this and I'm going to do some simplification. So first of all, when you square a fraction, that's like multiplying it by itself. So fractions multiply. By doing top times top and bottom times bottom. So that would be b squared over 4a squared. And now I have two fractions that I'd like to add together. Well, in order to add two fractions, they need to have the same denominator. This is 4 times a times a. This is just a. If I wanted to get the denominators to be the same, I'd have to multiply this denominator by a 4a. 4 times a would give me 4a squared. But to keep the equation, the fraction the same, I have to multiply the top by the same thing. So what I'd have then is negative 4ac plus b squared all over that common denominator. Now when I write this over into my equation, I'm going to flip the order on top. The b squared minus 4ac, and that's all over 4a squared. All right, now I'm ready to take the square root of both sides. So when I take the square root of the quantity squared, I get x plus b over 2a. And that's going to equal plus or minus the square root of this fraction. Now, square root of a fraction, you take the square root of the top and the bottom separately. The top has a subtraction in it, so you can't take the square root of things that are added or subtracted separately. So that's going to stay the way it is. But the square root of 4a squared, let's see. 4a squared is 2 times a times a. So I have a pair of 2's and a pair of a's. So that's going to be a 2a on the bottom. So what this simplifies down into is this. And now I'm going to get the x by itself. Change colors. I'm going to subtract b over 2a from both sides. And now I'm adding and subtracting two fractions that have the same denominator. So I keep the denominator the same and add and subtract the numerators. And this, ladies and gentlemen, is the quadratic formula. And we're going to use this more in class next time.